Hello everyone, my name is Sara Bouzit. I'm Head of Research and Insights at EPAM Systems. I'm glad to share with you this case study on using biometric methods in user research to decode users' decision-making process. Well, talking about the decision-making process, we know that humans are irrational, and 95% of our decisions are made unconsciously. And understanding how users make decisions require diving into the neuroscience. Here I put just an illustration of the brain. As you can see, we have different regions in our brain. For instance, you have a region responsible for our decisions, a region where we articulate our thoughts, but also a region which is responsible of our biases, where we form our biases. Now, what happens when we do traditional research, like user interviews? We ask users questions, they take time to reflect, articulate their thoughts, and then give us answers. And here, where we can see the gap between what people say and how they behave in reality. Now, the benefits of the biometric techniques is the fact that we are collecting physiological and non-biased data, real-time data, so we can reduce the gap between the say and do. And today I will share with you how we leverage biometric techniques in 3 different case studies. So let's directly start with the first one, which is an evaluation of a dashboard. Just to give you a bit of context, this project was for a client in the insights industry, a consultancy industry. And our client, they have an analytical dashboard to track brand trends and performance. And they wanted to enhance the user experience with this dashboard by designing a completely new layout. And the purpose of this study was to evaluate or to compare the old dashboard versus the new one and assess whether this new design contributes enhancing user engagement and reducing the cognitive load. We have designed a biometric testing and recruited 8 participants, and then we asked participants to perform multiple tasks. And while participants were interacting with the dashboard, we were collecting their physiological data. For that, we used a combination of biometric sensors, the EEG to scan the brain activity and measure the cognitive load and the level of engagement, the eye tracking webcam and screen recording to assess how users consume the information displayed to them, and the GSR, or the galvanic skin response, to monitor the fluctuation in emotional arousals as users go through the dashboard pages and interactions. And for the experimental procedures, first participants received an introduction and a consent form outlining the study objectives and the biometric sensors. Then the experimenter set up the EEG cap and the GSR device while ensuring participants' comfort. Then we performed eye tracking calibration by having participants track a moving dot on the screen. And then also we had a relaxing video was shown to establish the GSR and EEG baselines. And then participants were ready to start the test. Well, what did we find out? For the exploratory tasks, comparing old versus the new dashboard layout, the eye tracking data showed that users seem to have a more organic attention pattern on the new layout than the old one. And this natural and organic visual exploration contributed to reducing the overall cognitive load on the new dashboard. However, different levels of cognitive load were observed during the use and interaction of this new dashboard. For instance, an increase in the cognitive load and a decrease in the engagement level were observed with tiles with a large amount of information. Moreover, we observed through eye tracking data that users spent longer time than expected to perform some tasks as they tried to locate the features. There was a mismatch between users' expectation and the location of the buttons, which introduced a high cognitive load. So even though the new dashboard layout outperformed, it needs some improvement to reduce the cognitive load and enhance engagement throughout the end-to-end journey. Okay, so let's move to the second case study, which was a mobile app evaluation. This project was with a client in the automotive industry. They aim to enhance the mobile applications homepage to increase users' engagement and navigation. They have various design ideas, and they have developed 4 different versions of this homepage. And they wanted to assess which design version is optimal for increasing engagement and improving the overall experience. So for that, we used 3 biometric sensors, EEG, GSR, and eye tracking, similar to the first case study. And the main difference basically was the mobile testing environment, as we tested on mobile and not on desktop. 4 conditions, as I said, have been tested, including the control. Control was their current homepage of the mobile app, and 3 other prototypes. Let's name them prototype A, B, and C. And participants were asked to perform 4 tasks on each version or on each prototype, and we randomized the order of prototypes across participants to mitigate the learning effect. We have identified design versions that led to a higher cognitive load and loss of engagement. For instance, during the exploratory tasks, users experienced higher activity in the theta brainwaves due to the excessive textual information that they didn't find relevant, for instance, on prototype C and on the control version. Also, what we have identified is the fact that the icon design and labels impacted the level of cognitive load and the ease of navigation. And as a result, we help the client to define the design version that makes an optimal balance between user engagement and cognitive load by leveraging the positive aspects observed on each prototype. The last case study is a different one because it's an outside the lab study. And this case was a showcase conducted by 2 researchers aiming at demonstrating the capabilities of biometric sensors in revealing customers' in-store emotional journey, attention patterns, and engagement for our client in the luxury retail industry. So we have 2 researchers, as I said. The researcher 1 played the role of a customer in the retail store, while the researcher 2 set up the GSR sensors to measure the emotional intensity of the first researcher throughout the in-store journey. Additionally, the researcher who was playing the role of the customer was equipped with eye tracking glasses to gain insight into the visual exploration of the store and the interaction with the displayed items and the shop assistants, or the interaction with the shop assistants. And we broke down the experimental session into 4 different phases: store layout exploration, in-store product search, product assessment, and the last phase was the interaction with the shop assistant. So here are the findings. For the store layout analysis, using the eye tracking heat maps, we identified areas of attention and focus. So the ease of access to store products, including the layout and the pathways, impacted the customer engagement. For example, the researcher, who played the role of the customer, her attention went through to products that were explicitly displayed along the pathway, and products behind the pillars were ignored. Now, when it comes to the store navigation, The GSR data indicated that the initial product that caught the user's attention didn't generate emotional arousal due to crowded display arrangements and limited product information. And this information observation indicates that engagement decreases when customers encounter obstacles in reaching products, which highlights the importance of accessible and obstacle-free product displays, especially in the luxury shopping experience. Now, when it comes to the product assessment, through the eye tracking and the GSR analysis, we gained insights into how specific products and their design elements captured the attention and emotional engagement. And this observation invites further understanding of why visually pleasing displays didn't win over more complex product assortments. Last but not least, when it comes to the shop assistant consultation, we monitor the GSR activity to assess the reaction during this interaction. And we observed frustration and increased GSR activity when the participants experienced delays and perceived a lack of attention from the saleswoman. This observation suggests neglecting customer service can result in frustration, decreased engagement, and diminished interest in product, especially in the luxury industry. So these are the main the three case studies I wanted to share with you. Thank you for your attention.